already left the room once. We are going to start CO6, which is finding angle measures by setting up an equation to solve. What does this phrase right here mean we're using today?
Setting up.
Algebra, right? Whenever you talk about an equation and solving, we are going back to a little bit of algebra. So like I said before I started recording, geometry being that study of relationships, you've got these new words here, these new terms. You need to know what these mean, because without these, it's tough to know what the relationship is. And without knowing what the relationship is, you can't set up an equation. Okay? So it's all intertwined. An angle bisector is a SRL. Who remembers what SRL stands for?
Segment ray line.
Segment ray line. Whenever I put SRL, I'm just abbreviating segment ray line, because they're all have the same properties as far as being straight, things like that. So an angle bisector is a segment ray line that divides an angle into two congruent sections. That's why it's called a bisector. Bi means two, sector means section. Okay? And angle means angle. So an angle bisector is a segment, ray, or line that divides an angle into two congruent sections. For example, if I had an angle that looks like this, and an angle bisector coming from the vertex out probably looks like that. Okay? If this section of the angle is 30 degrees and this is 30 degrees there, I could show it's an angle bisector by putting in the actual measurements, and 30 is the same as 30. Or marking angles congruent a little bit further down the page here. An arc in the vertex of an angle, it tells you it's congruent to another angle of that same arc. So if I put an arc right here, an arc right here, without the angle measures, that would still tell you the angles are congruent. Okay? So that arc through the angle. And just like our conversation of congruency versus equality before, when you're talking about the thing, the angles, you use the congruency symbol. When you're talking about the measurements of the angle, the value of the angle, you use the equal sign. Okay, and we'll have more practice with that. But same kind of thing we talked about before. A linear pair. What does the word linear mean? Line. What does the word pair mean? Two. So a linear pair, two angles, and I'm going to add the word adjacent here. Do we know what the word adjacent means?
Next to equal word.
Next to each other, so they share a side. Two adjacent angles that make a line. And if two angles make a line, what's the degree measure of
90?
a line? 180.
Like 90.
It means they sum to 180 degrees. Okay, Tatum, what are we building over there? What? So a linear pair, two adjacent angles that make a line, which means they sum to 180. An example of this. Here's my line. I want to draw that in there. Okay. So I've got two angles there, right? Because here's a vertex. I've got angle 1 and angle 2. Those aren't the degree measures. Notice there's no degree symbol. It's just a way to mark them, a way to label them. Angle 1 and angle 2. If I tell you that this angle is 140 degrees, seeing that these two adjacent angles, they share a side, right? Those two adjacent angles make a line. What do you know the measure of angle 2 is? 40 degrees. Okay? I think I said before that if you can add to 90, 180, and 360, that's like half of what geometry is. Okay? Because there's so many different ways that 90, 180, and 360 pop up in the mathematical world. Vertical angles. Two angles that are opposite each other at a vertex. And here's the relationship with vertical angles. Vertical angles are congruent. Vertical angles are congruent. Two angles that are opposite each other at a vertex, vertical angles are congruent. An example, something like this. Okay, here's a vertex, angle 1 and angle 2 are opposite each other. At that vertex, it means they are congruent, and I can mark that with an arc in each of them. Is there another pair of vertical angles here?
Yeah.
You bet. If I label angle 3 and angle 4, they are also opposite each other at a vertex, which means their relationship is also congruent. Only I can't mark them with one arc because I don't know if they're the same as angles 1 and 2. So 2 arcs. Good job. Okay? The 2 arcs tell me that angles 3 and 4 are congruent to each other. The single arcs tell me 1 and 2 are congruent to each other. And I know that they're vertical angles, 1 and 2, and 3 and 4, because they're opposite each other at a vertex. What's that? The way I drew my arcs, here, let me draw that. Let's do that one. So like, this would be congruent to that one, and then, I still get circles in the middle. Those two would be congruent there. Look like a smiley face.
Nice.
Kind of.
It looks like some pet
Yeah, well.
Why do the middle, like go from left to right, so it goes together?
I don't know. That's a good question, Hugo. I don't know. Aiden.
Can vertical angles have more than two congruent angles?
No, vertical angles are only 2. Yeah, that's a good question. Yeah. Congruent means the same as.
So it's equal.
Equal means the same value.
Like that.
Objects are congruent. Things with value are equal. Okay? Things with value are equal. The angle addition postulate. What was the segment addition postulate again? Back in CO2? The segment addition postulate? Yeah.
The parts of a segment add to the whole.
Add the parts of a segment add to equal or sum to equal the whole segment. This is very similar. The parts of an angle sum to equal the whole angle. The parts of an angle sum to equal the whole angle. Yay! No time done. You okay? All right. Questions on any of this stuff? Yeah. Huh?
So what?
What? Yeah. Sure. Evan.
What's postulate?
Postulate? Postulate is like a mathematical property. It's a rule that we know to be true.
Like a house?
Not like a house. Not like that kind of property. No. All right, here we go. It's all about relationships. It says plug in the value of x and verify that everything fits together. That's how you can check your work. Our task here says find the requested angle measure and then check your answer by verifying that the relationships work. So this is another way to identify an angle. I use numbers higher, angle 1, angle 2. Here I'm using letters. So if I'm identifying angle ABC, the letter in the middle is the vertex of that angle. So what this is saying is it's going from point A, that comes first, down to point B, and then up to point C. That would be the angle ABC.
Does the order matter?
The order matters only that the vertex is in the middle.
So we could do CBA.
CBA would be the same angle, from point C to point B to point A. Okay? ABC, CBA is the same angle. We also want angle CBE. Now notice CBE starts at point C. Again, B is the vertex, it's the one in the center. And this one goes down to point E down here. So we're looking for those two angles.
What does the M stand for?
The one in green and the one in red. The little italicized M stands for measure. So we're looking for the measure of angle ABC and the measure of angle CBE. So in order to find that measure, we need to come up with some sort of relationship. Right? And judging on what we just talked about up above, do we have a linear pair? Do we have any vertical angles? What is something we can use, Aiden?
Or we have a linear pair.
We do not have a linear pair with the 2x plus 7 and the 4x minus 14. Those do not make a linear pair. And the reason why is because these are not adjacent. These two angles don't share a side. Okay? These two angles are what we call vertical angles. Look at the picture that we drew, right? These are two angles that are opposite a vertex. Christopher, what's the relationship between vertical angles?
They're opposite.
Okay, that describes them.
They're
What's the
congruent.
relationship?
They're congruent.
They're congruent, which means their measures are equal. So the equation we can set up, we can say that 2x plus 7 is equal to 4x minus 14. Right? Recognizing they are vertical angles and knowing the relationship that they are congruent, they have equal measures, we can set up this equation to solve. And now we get to do a little bit of algebra. Okay? We can move our 2x over. We can move our 14 over. And we get 21 equals 2x. Right? Well, over here, 2x minus 2x equals 0. Negative 14 plus 14 equals 0. We get our variables on one side, constants on the other side. And what does x equal? 10.5. Okay? Which is not the answer. The answer is, what is the measure of angle ABC? Okay, well, if x is 10.5 and ABC is 2x plus 7, then 2 times 10.5 plus 7 equals what?
28.5.
28.
28. Right? 2 times 10.5 is 21. 21 plus 7 is 28. So the measure of ABC is 28 degrees. I should write that in green, huh? Measure of ABC is 28 degrees. Now, it says up here, you can check your work by plugging x back in. What else should equal 28 here?
4x minus 14.
4x minus 14. DBE should also be 28 because that's how we got this relationship. We said these two things were equal because they are vertical angles. So just to check our answer here, 4 times 10.5 minus 14, well 4 times 10.5 is 42, minus 14 does equal 28. So the relationship checks out. Okay? But now we got to get this angle here, angle CBE. What's the relationship between, I'll mark them with a dot here, angle ABC and CBE? Hugo?
They add to 180.
Because they are a
Linear pair.
linear pair. They are two adjacent angles that make a line. Right? Our line is right here. These two angles make this line, therefore they sum to 180. They are a linear pair. And so, 180 minus 28, because of 28 we know that ABC here is 28 degrees. 180 minus 28 is 152. And that's going to be the measure of CBE. So you see how these relationships matter? Okay? Being able to being able to recognize when two angles are opposite each other at a vertex, what that means. Recognizing when two adjacent angles make a line, what that means, and the equation you can set up to solve it.
Yes. So is 152 also for DBA?
Yes, so DBA would also be 152 because that's a vertical angle with CBE. Very good job. Okay. The next one, we're looking for POR and ROQ, but just, what can you tell me about those three angles? They're not technically a linear pair.
Or a linear tree.
A pair is only two angles, but they do, all three of them together make a line. So what's the equation we can set up for this?
Well, it has to equal 180.
Yes, the angle measures of the three of them have to equal 180 because that's the measure of a line. So what's the equation you would set up? 80?
5x plus 4 plus x minus 2 plus 3x plus 7.
Equals
180.
180.
Oh, yeah.
Yeah. The three measures of the angles all have to add up to equal 180 degrees because the three of them make a line.
180.
So now we got some like terms here. We have 5 x's here, another x there, 3 x's there. Total that's 9 x's. Positive 4, negative 2, positive 7. Total that's positive 9. So we have 9x plus 9 is 180. Nice two-step equation to solve here. Subtract 9 from both sides. 9x is 171. Divided by 9, x is 19. Which is not the answer. We're looking for POR, which POR goes from point P to O in the middle, that's our vertex, up to point R. So angle POR is actually two angles put together.
So,
Right?
but
But we
they
know
should add
that.
their equations.
The angle addition postulate tells us that these two angles added together will equal the whole angle of POR. So 5 times 19, 95, plus 4 is 99. X minus 2, 19 minus 2 is 17. POR would be the sum of those pieces, the sum of those parts, and that's going to give us 116 degrees. Then ROQ, going from point R down to point O, over to point Q. 3x plus 7, 3 times 19 is 57, plus 7 is 64. We could have also, of course, just subtracted 116 from 180 to get 64, because they do add up to be 180. And there we have it. This is the objective where you start to see why these relationships matter and how they are used. You have to know what vertical angles look like, as well as their relationship. You have to know what a linear pair looks like, as well as its relationship, and then how to set up the equation to solve it. Good, I'm glad. Your homework for tomorrow.
Oh, we can't check the tape.
Might have time.
There's 1 minute left.
Oh, better hurry up. Let's see.
No homework.
Yes. Cancel homework.
I gotta give it something. On page
You're guilty.
29.
No.
Oh no, let's do this instead. Actually, yeah. On page 29, 22 through 26. Page 29, 22 through 26. That's only 5.
Don't say that.
Yeah,
Oh.
That's 4.
That's a lot.
5.
And then 33 to 38.
No. My free time.
Oh, they're not that bad. And that's it.
Alright, check them.
Okay. No time for review.
That
That is how you math.
Don't forget the microphone.
Check
You gotta roll the tape.
Always
Still gotta roll